All right, page 2 starts with number 4. It says $900 is invested in a money market account that earns 1% interest annually. How much money will be in the account after 12 years and after 20 years? Okay, so when you're talking about the money and the interest rates and all that, which is kind of what that last one was talking about, but when you get specifically into money and you're talking about investments, we go ahead and use the formulas principal 1 plus r to the t versus amount equals principal times 1 plus r over k to the kt, where k stands for the number of times you compound per year. So if it's annually, k is 1, that just means we're at this formula right here. So it did say annually for this, so let's go ahead and say amount equals principal, which is 900, times 1 plus 1% interest, so 0.01, to the t if I need the function, but it says after 12 years, so I want to know what it is when t equals 12, and then when t equals 20. So I just type it in, 900 times 1.01 raised to the 12th, and I'm left with $1,014.14. And then if I change that to 20 instead of a 12, then I've got $1,098.17, which is not very much in interest for 20 years. $98.17, but that's because it's 1%, and we never added any money. It was just and it was annual compounding. Pretty bad deal all around. Alright, now it says B, what if the interest is compounded monthly? So the first one was annually and this one is monthly, so that means amount equals principal, 900. Oh, and it was a small amount to invest. Oh, not $98. It was 198, because you gotta go from 900. 1 plus r over k, so r is 0.01, k is monthly, so that means k equals 12, raised to the 12t. So that's the general formula. I just got a lot larger. And if I want t to be 12 or 20, then I just go in there and I change it. So 900 times 1 plus 0.01 divided by 12 raised to the 12 times after 12 years. It'll be $1,014.70. And after 20 years, if it makes you feel comfortable to do the fraction bar, you can say 900 times 1 plus alpha y equals 0.01 divided by 12 raised to the 12 times 20, and you get $1,099.17. So you can see how with that small of an interest rate and that small of an investment, the difference between the amount of money you're going to get compounding monthly versus compounding annually is not that much. Okay. What if the interest is compounded continuously? So continuously is a third formula. Amount equals principal times e raised to the rt. So e is an irrational number that we use when this expression, when k approaches infinity, which is the number of times you compound. So we just got amount equals principal times e raised to the r, 0.01 times t. And in this case, we want t to be 12 and 20. So 900 e, and e is in two places, above the division symbol and above ln and e to the x. That's the one I always use beside 4. So 900 times e raised to the 0.01 times 15, just kidding, 12. So for 12 years, I've got $1,014.75, a whole 5 cents more than the last one. And when I want it to be 20, I'll just type that in. I've got 1,099 and 26 cents. Okay. So it's going to be very important that you read the information. This is compounded annually, this is compounded monthly and continuously. We've got these 3 different formulas, and I don't know that I'm going to let you have them during the test other than if you remember them. We shall see. Okay. So 5,000, number 5. 5,000 is invested in an account for 25 years. What interest rate is needed to make the account worth this much if it's compounded quarterly? Okay. So the information is the initial amount, the time. R is what I want. I know the final amount, and I know that it's compounded quarterly, so I know what K equals. So my final amount is 9557.58 equals initial amount, 5,000, times 1 plus R is what I need, over K, which is 4 because of quarterly, raised to the 4 times time, which is 25. So I'm trying to solve this expression right here. So what I can do is go ahead and do that intersection thing again. So I'm going to go to y equals, clear out what I have. I've got 9557.58, 5,000. Times 1 plus x divided by 4 raised to the 100. And I'm trying to find R. So, okay, go to window. X represents rate. Y represents money. It always does. So here I know I'm going to go 0 to 10,000. I'm probably good. Rate, however, when you think about the numbers that we're putting in for rates, like the problem before is 0.01. The problem below this is 3% and 3.26%. So we're not talking huge numbers. We're talking very, very tiny. So I'm thinking 0 to 0.1, which is 10%. And I'm never going to see that, so I might as well just make that my max. So 0 to 10%, so 0.1. And 0 to 10,000. And a graph. And there we go. So second calculate, as soon as it's done. Number 5, enter, enter, enter. And I find that my interest rate would be 0.026 or 2.6%. And so 0.026 is the x value we found. Okay. A certain type of bacteria can double every 3 hours. Oh, this is the one where I didn't give you guys an initial amount, right? What did we say, 43? Weirdo. Okay, so the initial amount is 43. And it doubles every 3 hours. Write an equation representing the information. Use it to determine how long it will take until there are 10,000 bacteria. So, okay. When I'm doubling, then I have 100%, which is the initial amount, plus another 100%. So when you think about the 1 plus or minus r, this is 1 plus 1 because you're doubling. Or it's easy to think, like if I'm doubling, then it's just times 2. So if my initial amount is 43 times 2 raised to the, well, I need it to double every 3 hours. So I need my doubling time not to be like every 1, 2, 3, 4, 5 and multiply by another 2. I need it to be divided by 3, so it's only every third x value that I get another double. Okay? So if I plug in 0 here, I get 1, or 0. If I plug in 3, I get 1. If I plug in 6, I get 2. If I plug in 9, I get 3. So it's every third that you multiply by another full 2. So this is my amount of bacteria in general. 43 times 2 to the x divided by 3. I want to know how long it takes. So basically I want to know what x is, what time is, for this to equal 10,000. So I use my calculator. So I'm going to go to y equals, clear them out. 10,000. 43 times 2 raised to the x divided by 3. I think about window. Window, x represents time, so hours, I don't know. Let's go 0 to, let's go 20 hours and call it good. And then I need to be able to at least see 10,000, so 15,000. And that is not going to be enough. Okay. So I know I need to go to the further to the right. So I'm going to try, I might as well try 100. Don't have to worry about it. Oh, there you go. Okay. So second calculate. Number 5. Enter, enter, enter. And I get 23.584 hours, which is almost 24 hours. So, and almost a day. Don't forget to write it in the answer. We're asking how long will it take, and the unit for time is hour, so it is 23.584 hours. Okay. The population of koalas in Australia is increasing by 3% each year. If there are currently 10,000 koalas, about how many will there be in March of 2027? Okay, so there are currently 10,000. They're increasing by 3% each year. And I want to know how many there will be in March of 2027. So unless this is something about compounding and we're talking about investments, you don't need to use that R over K to the KT or PERT. We're talking about just 1 plus or minus. So see what it says. Each year. Okay, each year. So, March of 2027, so we're 2017, something in 10 years. It says March. Let's go ahead and say 10 years and call it good. As far as time goes, I guess it'll be 10 years in a month, but I guess we could say 10 and 1/12 if we wanted to. 10,000 times 1.03 raised to the 10th. So we're talking 13,439. Now, normally I like 3 decimals, but I'd like you to write it down so that I know you found the exact, but then that you know that it is just, we're talking about an animal. So we're not going to have percentages of an animal. So we'll just go ahead and say round to a whole number. Okay. If $10,000 is invested at 3.26% interest in a compounding continuously account and is worth this much money when it is closed, how many years do they accrue interest? So accrue just means accumulate. So $10,000 was invested in a compounding continuously account, so e to the r 0.0326 times time. It says how many years, so that's what I want to know. Did it take for it to equal $16,440.29? Okay, so let's Y1, Y2. 10,000 e, not that, e raised to the 0.0326 x, and then I want to know when it equals 16,440.29. T represents time. I'm going to go 0 to 50, and I need to be able to see $16,440.29, so I'm going to go 20,000. And I press graph. Second calculate 5, enter, 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 and I get that time equals 15.249 repeating. So if you said 249 years, that's fine if you truncated, but if you rounded it would be 250 years. It's okay if you said 15.25. Okay. Now the 9 through 20 has to do with a lot with logs. So there's some that you might have not seen before, guys. So when I get to problems 14, 16, you might want to pay attention. Okay. So rewrite each equation in exponential form. The base of the log is the base of the exponent. So x to the, it can't be x to the 52. It can't be on the same side of both. So x to the y equals 52. And then on this one, the base is v raised to the u equals 36. You need to make sure that I can tell which one is the base, which one is the exponent, and that across the equal sign is in line with the base. Write it in log form. I don't know why I keep twisting it. So this is log base. Well, the base of the log is the same thing as base of the exponent, so log base 16. It can't be of n, they can't be on the same side on both, so of n, and these need to be in line with each other, equals m. And this next one is log base y of x equals 18. So base of the log is the same thing as base of the exponent. They can't be on the same side in both versions, so there we go. And those need to be in line. Okay, evaluate without a calculator. So one thing you got to remember when we evaluate logarithms is that the log and the exponential are inverses of each other. So when you think about log base k of k to the m, what happens is that these two operations, the log of the exponential, if they're the same basis, base of the log, base of the exponent, you're just left with the power. So when I look at this, I think about 64 and I think, okay, 64 is 4 cubed, so the answer is 3. This does come down as multiplication, and we'll talk more about that later, but so it's not like a power. Okay, number 14. I need to be able to rewrite 7 as 49 to some power. So when I think about this, let me see this. If I were trying to solve this, then I would say, okay, log, so you can think of it like that. Log base 49 of 7 equals what? Well, if I convert that to an exponential, then I can say 49 to the what equals 7. Yeah? So 49 to the what power? Well, I know that the square root of 49 is 7. So if I think of it like that, I can think, well, it's 49 to the 1/2 power. Yeah? So right here, if I can rewrite 7 as 49 to the 1/2 power, then I know that these cancel out. My answer is 1/2. It's important that you know how to do this without a calculator because you won't have one on the test when you do that problem. So on number 15, the power of 5, it's a base 5 and it's a power of 5, or it's a, well, they're both bases of 5. Base of the log, base of the exponent is an understood 1, so the answer is 1. 64, well, so just like over here, we said 64 is 4 cubed, which means 4 is what, guys? 64 is the cubed root, right? Sorry, 4 is the cubed root. If 4 cubed is 64, then the cubed root of 64 is 4. So I can rewrite this as 64 to the 1/3 power, and I'm left with 1/3. You will have a power chart, you will not have a calculator. Okay, on this one, what I need to do is think of it 81 as 3 to the 4th, yeah? Yeah, but it's in the denominator, so if I bring it up, then it is log base 3 of 3 to the -4th, which means my answer is -4. I'm sorry that I keep twisting it. It's just how I write. I should just turn the camera with it. Okay, and then when I think about this, if I don't know what that equals, then I could say 7 to what equals 1? Well, 7 to the what power equals 1? Guys, 7 to the what power equals 1? 0. Good. So anytime you have this, you can rewrite 1 as 7 to the 0 power. So the answer is 0. Log of 1 is always 0. Number 19. 64 is 8 squared. Bring it up. It's 8 to the negative 2. Log base 8 of 8 to the negative 2 is negative 2. And 4 is 2 squared, so the answer is 2.